Welcome to another tutorial of Proflan YouTube channel. In this particular video, we are going to have a discussion of topical questions, most common topical questions that will appear in the May June exams, especially in Math Paper 2. So if you are new to Proflan YouTube channel, consider subscribing so that anytime we're going to upload this series, you'll be notified. Also, you can leave a comment down below. If there is any area that you feel that if I go through it, it will be able to accelerate your grade towards grade 9. So one of the area that you need really to look at is converting recurring decimals to fractions, and especially you may be given a question like this that I've displayed here that use algebra to show that 0.372 recurring, and we can see now the values that are recurring in this values that are recurring here. We are given 0.372. Now in this case here, 72 is the one that is recurring, meaning that this expression that we have here can be written 0.3 72 72 72 72. So meaning 72 is the part of this decimal that is actually recurring. That, and we mean by recurring, it's repeating itself. So meaning that now, how are you going to approach this question? We are going to say let x be equal to this part that we are given, correct to 3 decimal places, and this is going to be 0.372. If we need to multiply by 10, we shall say 10x is going to be equal to, so we shall move the decimal to that particular point. So that will be 3.727. So what we are going to do here, we shall keep on moving the decimal in that way until we have a situation whereby if we can subtract the two numbers, we can be able to get a 0 after the decimal point. So because you see now after the decimal point here, we are having 372, here we're having 727. So if we subtract the two, there's no way we're going to get a decimal, so we have to continue. So we need to multiply by, we need to have 100x. Now the decimal must have moved to this point, so this becomes 37.272, because we shall be writing this correct to 3 decimal places. Then can you see anywhere you can be able to subtract and get a 0 after the decimal? This is 372, 727, no, 272, so still not yet. So we need to move the decimal further one step. So now we shall have 1000x is going to be, now the decimal will be at this point, because you'll move with 1000, we are going to move this decimal 3 steps, 1 2 3, so the decimal will be here. So we shall have 372.727. Now I feel that at this given point there is a point where if subtract we can be able to get a 0 after the decimal point. So for instance, look at this is 727 and this is 727. So we are going to use this part here and this part here in order now to work out this decimal. And how are we going to do it? We're going now to say that 1000x is equals to 372.727, 372.727. Then we also have, we have already written this, we shall also say this is 10x is equals to what? Is equals to 3, there is a decimal here, 3.727. Then we are going to subtract the 2. Now once you subtract the 2, this is going to translate to 990. X is equivalent to If you subtract this using your calculator, what are we going to get? If you subtract that, you are going to get 369. We are going to get 369.0, because now 727,727 is going to cancel, and that is the main objective. That's what we wanted in this particular question. So we now have 97. Okay, we have 990 x, which is equal to 369, divide by 990, divide by 990. This will cancel out, and we are going to have x, which is going to be equivalent to, let me just use my calculator here. Let me just say this is 369 divided by 990. So if you put that in your calculator, can you check? The answer is 41 over 110. So we have our answer as 41 over 110, which is exactly what we were supposed to show in this particular question. So those are the steps. So ensure that you keep on practicing comparing decimals, so that you can be able to work out question related to that. All right, so we need to move to the next question that is very, very common in Igcse Edexcel exam. Here we are given SATs, and SATs here we are told that express root 125 plus 180. We are having root 125 plus root 80 over root 3 in the form of root n, and we are told that n is an integer. You are supposed to show all your steps here, so meaning that we can be able to simplify this, and in the process of simplifying this, we can say this root 125, how can we be able to express it? Root 125 can be written as 5 times 25 plus root 80 can be expressed as 16 times 5 over root 3. So which means that at this given point, see, we are having this 25 here, and we are having this 16 here. These are values which you can be able to find. They are square roots. We can be able to say this can also be written as 5 times root 25 plus root 16 times root 5. So meaning that this one is going to be over root 3. Yeah. So let me just try to move this writing here, so that we can have enough space to work on this question. So we can be able to say root 25 is actually 5. So this is going to be root 5 times 5 plus root 16 is going to be 4 times root 5 all over root 3. So which means that this is going to translate to what? This is going to translate to 5 root 5 plus 4 root 5 divided by root 3. So I can see that this part now can be written as, because this is root 5, I can add 5 and 4, and I'm going to get 9 root 5 over root 3. Then we're going to rationalize the denominator, and this is going times to be root 3 times root 3. When you rationalize the denominator and you're having a single value like this one, what you are going to do here, you just multiply the weight. But if you are having two terms, you are going to use a conjugate, which we had learned. So meaning that this is going to be actually root 5 times root 5, because both of them are under this under the square root, because if you're having root a times root b inside, that means root a times b. Yeah, so 5 times 3 is going to give us 9 root 15 at that point, over root 3 times root 3 is going to be 3, then this is once and this is going to be 3 times. So which means that we can simply say this is 3 root 15. So if you want to take these 3 inside here, remember, if we were having root 25 here, to take it out, we will find the square root of 25 and take 5 out. That's why we were having actually this 5 at this given point. Oh, let me just maybe illustrate that. If you're having 3 times 25 root, you can say this is going to be 5 root 3. You will find the square root of this number and take it outside the square root. But if you want to take this 5 inside the square root, it means you are going to square this number, then you multiply it by 3, so that you are going to have root 3 times. Now you square 25, you get 25 the way it was here. So you can be able to remove numbers from inside a square root, or you can be able to take them out, or you can take them in. So meaning that now at this given point, if I want to take this 3 in, I'm going to square it, then I multiply by 15. So that would be 9. 3 squared will be 9. Then 9 times 15 is going to give us 135. So this final answer here is going to be root 135. Root 135, the way we were supposed to give it in the form of root n. All right. That a particle is moving along a straight line that passes through the fixed point O. The displacement s meters of the particle from O at time t seconds is given by s equals to, we need to write that, s equals to 2t cubed minus 5t squared plus 6t minus 5. So find the value of t when the acceleration of the particle is 5 meter per second square. So something you need to understand that v is going from acceleration from displacement. If we differentiate a displacement equation, we're going to get velocity. So v is ds dt. So this is the symbol that means differentiate. And when you are differentiating this, you are going to take this power down, you multiply it with the number in front here, that becomes 6t, but the power decreases by 1. You are going to subtract 1, you are going to have 2. Then also we take the power down, it becomes minus 10t, then 2 minus 1, you are going to remain with 1. So we just write t like that. This one is 1 here, we shall take 1 down times 6, it will be actually plus 6. But t minus 1 minus 1, we are going to get 0. And n number raised to 0 is 1. So 6 times 1 is going to be 6, like that. So we have the velocity equation, v equals to 6t squared minus 10t plus 6. So if you are supposed to find acceleration, acceleration is actually dv dt, which is going to be also, this is going to be, we shall take 2 down, and that's going to be 12t, because t 2 minus 1, we're going to get power 1 here, and then we shall have minus, this is like 1 here, you multiply by 10, it will be minus 10. Then 1 minus 1 to be 0, and then t raised to 0 is actually 1. So we are going to have this as an expression for acceleration. So we can say acceleration equals to 12t minus 10. Okay, so once we have that, we are going to, because we are told we are finding the acceleration with the time when acceleration is equal to 5 meters per second square. We were told that we find t when acceleration is this. So meaning that we can say this is 12t minus 10 equals to 5. We can take 10 the other side. We shall have 12t equals to 15. Divide by 12. This implies that our t is going to be 5 over 5 over 4, which is actually equivalent to 1.25 seconds. 1.25 seconds. So basically, that's what you are supposed to do when you are given questions like this. All right, so moving to the next part here, whereby you are given question to do with you can be given so here we are told that we are supposed to find the upper bound of p. Now for you to find p upper bound, we are going to use a upper bound into c upper bound plus y upper bound. For you to get p upper bound, you must multiply the upper bound of a times the upper bound of what's in the bracket, because if you are going to use upper bounds, let me just try to adjust this. Yeah, right. So if you can be able to use the upper bounds, you'll be able to get it like that. So let's now try to analyze a. A was actually equivalent to 8.3. Now, something that you need to ask yourself is the accuracy that is given in these particular questions, because we are told that 8.3 correct to two significant figures. So if it's correct to two significant figures, these actually two significant figures, it means the least unit that can be measured in this given point is 0.1. So least measurement is 0.1, because it's correct to two significant figures like this. So which means that in order to get the absolute error plus or minus, we are going to divide this by 2. The least unit divide by 2, and this is going to be 0.05. For C, here we are told that is correct to one significant figure. Correct to one significant figure. So we are having 2 plus least unit for one significant, correct to one significant figure. The least unit here, because this is actually 2, the least unit in one significant figure is going to be 1. So 1 divided by 2 is going to be 0.5. So it's plus or minus 0.5. Then we have y, and the value of y is actually 15, and to the nearest 5, it means the least unit that can be measured is actually 5. So to know what we need to add or subtract as the absolute error is this 5 divided by 2, which becomes 2.5. So in each of them, we need to find the upper bound. And the upper bound in this case, we're going to add the absolute error. So this is going to be 8.35. This one upper bound is going to be 2.5. And upper bound of this one is going to be 17.5. So meaning now, for us to actually find P upper bound, this is going to be equivalent to A upper bound, which is 8.35 into bracket C, which is 2.5, then plus 17.5. So if we can be able to put this in a calculator, we are going to say that this is actually 8.35 into brackets 2.5 plus 17.5. So if you work it out, you are going to get nothing other than 167. So the final answer becomes 167 as the upper bound of P. So until tomorrow, another one, more topics to come. Consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. See you in the next video.